ROS developers, and welcome to a new Open Class number 146, where we are going to be talking about ROS2 Navigation and more specifically about how to set the initial pose. Different methods of setting the initial pose for the localization system in ROS2 Navigation. So yeah, let's get started. Then let me know please in the chat, first of all, if everything is fine, image is fine, sound is fine. Let me know so that I can continue without worrying about it. And yeah, so let's not lose any more time and let's get started. Then the first thing I'm going to do right now is to switch to my computer, to my PC view, and log in so that I can get access to the chat and everything. Let me open the class page. Here we are. Okay, I don't see any messages so far. So hopefully everything is fine. Then, yeah, so in case that there is any, I can see now Bibin Thomas says hi. So I assume that everything is all right. You can hear me properly. Image is also correct. Then, yeah, let's get started. So as always, the first thing that we need to do in order to get started is to click here in the fork and open the class ROSject button, this light blue button that you have here right above the chat. So I'm going to click here myself. Now everybody is saying hello, hello Logan, Dami, Parves, hello everybody. So yeah, let me click myself here. And this is going to create a copy of today's ROSject into your space, into your account. So you are going to have this copy forever, okay? Important to state that you are going to have this ROSject forever, so you can review it anytime you want. Yeah, to keep working on it, doing some modifications, reviewing what we are going to be doing today. So yeah, you are going to have a copy of this ROSject in your account forever. Okay. Then here in the right side, you are going to have the streaming area with the live stream here, the chat, etc. And then this is going to take some seconds in order to load everything. So hello, Nuria also. Yeah, so apparently everything is okay. Great. Then, yeah, so all of you, please click on the fork and open the class ROSject, which is going to take you to a page similar like mine. And then we just have to wait a few seconds until everything gets loaded to get started. There we go. So here I have some things opened by default. Let me close them. All right, and what you're going to get is something like this. So the Jupyter notebook is going to get automatically opened. And yeah, so just make sure that you have the correct one. It's the one for the class number 146. And yeah, so this notebook contains all the instructions, all the steps that I'm going to be following and that you are going to be doing alongside with me during today. So here you have everything that you need. Yeah, in case that at some point you get lost, you can come back here and see where we are. All right. So yeah, let me know please in the chat if you have been able to load the ROSject properly. Any issues so far? Everything is good. Hello, Igor. All good. Perfect. Then just let me remind you very quickly that, yeah, so I'm going to be running some commands, creating some scripts, even some files, etc. And I want you to be doing it with me, okay? So this is an interactive class where I'm going to be doing things, but since you have the same copy of my ROSject, you can do exactly the same that I'm going to be doing. Okay, and you should do it because this is the way that you are going to get the most out of this class. All right. Then the first thing that I'm going to do, that we are going to do, is to start a simulation. Yeah. So we are going to be working with a simulation here with a Turtlebot 3 burger. So yeah, let's get started. And then the first thing that we are going to do is to open a new shell, a new terminal. Yeah, by clicking on this icon here in the bottom bar. So let me click here myself, and this is going to open a new blank terminal where you can execute Linux commands. So nothing strange here. And in this case, I'm going to be running these two commands that I have here to start the simulation. Yeah. So I suggest that you copy them directly from the notebook and paste them into the terminal to speed up things, so that you don't have to write everything manually. So yeah, I'm going to start copying the first command here, this source command, and pasting it here. And now let's go with the second one, which is an SH script that basically it's going to start the simulation. There we go. So the processes are going to start here, and you are going to have this gazebo window opened where you are going to be able to visualize the simulation. After some seconds, it takes some seconds to fully load. So you just have to be a little bit patient. All right. Okay, then meanwhile, my simulation is getting loaded. What we can do is to open the code editor, the IDE. Yeah. So this is the second icon, the one that you have right side the shell icon, this one here, which says code editor. And if you click here, this is going to open another window which contains the IDE, the Integrated Development Environment, where you are going to be able to visualize all the workspaces, directories, files, packages, everything that this project contains. Okay. For instance, you can come here to the ROS2 workspace, SRC, and T3 Foxy folder, and here you can open the start simnav sh, which is the script that we have just executed. You can see what it contains, etc. Okay. Just in case that you are curious. Not this one, but the one that we have executed is this one, start sim nav. All right, then let me go back to Gazebo because the simulation should already be loaded. There you go. Okay, so after some seconds, you should get a simulation like this one. So let me come here and let me see. Yeah, so this should be working. All right, so for some reason, my client seems to be bugged. I cannot click on it or interact with it. I don't know if this happened also to you. So what I'm going to do is to just restart it. Okay, so I am clicking here, trying to interact with the client, but nothing happens. So yeah, let me restart it. Let me stop it. Did you have the same issue, or it started properly for you? Let me kill here the processes. It works. Yeah, it should work okay. I don't know why for me. Okay, strange. I'm going to close this. Yeah, then if it works, don't worry. I'm going to restart this very quickly. 12. Let's see. I'm just manually stopping the processes right now, as you can see, with the kill command to make sure that I don't have any background gazebo process going on, which is somehow interfering. Okay, so let me start it again, and hopefully now it's going to go all right. Let's see. So here I have my gazebo window. Yeah, some error messages might appear here, but you can just ignore them. Okay, they are not important. So let's see. Let's see if this works okay for me now. Okay, yeah, so now it's working okay. I don't know what happened, but yeah. So yeah, then you're going to have something like this. As you can see, you have the Turtlebot 3 robot here, the burger, and it's in this environment here, in this kind of scenario, yeah, with these piles here. So yeah, then we are set up and ready to start. So today, the topic for today is how to set the initial robot pose in ROS2 Navigation. Okay, there are different ways. So first of all, I'm not going to go into details about localization. So just get the general idea. Probably most of you already know what is localization. But localization basically means knowing where your robot is located with respect to an environment, with respect to a map. Yeah? So for navigation, you are going to create a map, and then once you have the map, you need to be able to localize your robot in the map. Yeah, this is the concept of localization in ROS2, and it is solved by using the AMCL approach. Yeah, so this is an algorithm which has been already developed by the ROS2 developers team, and it's pretty robust. It works quite well. So yeah, this is the approach that we are going to be using, but I'm not going to go into details about this, okay? So for this class, we are going to assume that all this is already set up and working, yeah? This is why here inside the ROS2 workspace, I already have the map server to provide the map and the localization server to run the localization node, yeah? So we are going to get started by directly launching localization, our localization system, yeah, which is done running this launch file from the localization server package. Okay, all this is already provided to you in this project. You are going to be able to see all this. You can have a look at the files if you want, etc. Yeah, but we are not going to go over it. It's not the point of this class. So right now we are going to start our localization system. Then for this, let's open a new shell. We are going to leave this one here running because it's where we have the simulation running. So if we close it, the simulation is going to die. We don't want that. So we are going to open a new blank shell by clicking on this at here, this plus icon. Yeah, so let me do it and open a new shell. And here I'm going to source, first of all, my ROS2 workspace. And then I'm going to run my localization system with this command. There we go. So this is going to start launching the localization systems. And at some point, when everything is started, you are going to start getting this message, right? It says, AMCL cannot publish a pose or update the transform. Please set the initial pose. Yeah, you're going to start getting this message as I am getting right now, right? What does this mean? This means that in order to actually start all the AMCL, as you can see in Node, we need to provide an initial pose for our robot. Yeah? We need to say, hey, initially my robot is here. Okay? Then once we set this initial pose, all the localization system is going to really start and get started, right? Then how can we set this initial pose that our AMCL node, our localization node, is asking us? Well, there are different ways in which we can do this, okay? One of the most common ones is doing it manually using RVs, okay? So let's start by this method, which is probably the most common one, yeah? Then for this, we need to, of course, start RVs. So we are going to open yet another shell, okay? We need to open a third shell. So let's click here in the plus button to open a new shell. And here we are going to start ROS2. Okay, ROS2. So let's remember that all this is ROS2 based. Yeah, so we are currently working in Galactic, ROS2 Galactic. Yeah, this project is based in ROS2 Galactic. All right. Then once we start ROS, we are going to launch a configuration file, an ROS configuration file, which is named like this, localization.ROS. And you can find it inside the localization server package. Yeah, so we are going to load this configuration file so that we don't have to configure ROS from zero. Then how to load it? Very, very easily. So you come here to the ROS window and click on the File button. File. Now we are going to click on Open Config. Okay? And now we have to browse here. So if you double click here in User, you go inside ROS2 Workspace, SRC, Localization Server, you're going to find here an ROS configuration file, which is named localization.ROS. So now you can just click on Open and discard, for instance, and then this configuration file is going to be loaded. And now we can see our map here, right? All right, so what now? So now, in order to set the initial position, as our AMCL node is asking, we are going to make use here from ROS of this 2D pose estimate tool that you have here in the upper menu. You have one of the buttons, which is 2D pose estimate. If we click here, then we can set here in the map an initial pose for our robot. Yeah. For instance, let's have a look at the robot. So initially the robot is here. Let me orient it better so that I can get a better idea. All right, so my robot is here in the middle, right? Between these two columns here. So I would say that approximately my robot is around here. Yeah. Then now, making use of this 2D pose estimate, I can select the position in the map and also the orientation. Yeah. So you are going to click and keep clicked the button, and then you can set the orientation. So I'm going to set the orientation like this, for instance, and then now I release the button, and the initial pose is going to be set. There we go. Yeah, so my initial pose has been set here. Right? Then I can see a couple of things here. First of all is this large red arrow, which is the pose with covariance. Yeah, this is the current pose that the AMCL node thinks that my robot is, which is exactly the pose where I have set my robot to be using the 2D pose estimate, right? And then I have also all these red points, which are the particles of the filter. Yeah. At this point, they are very dispersed, but if I start moving my robot around, these particles are going to get closer, are going to converge into the actual real robot pose. Yeah, as I move the robot around and I get more data from the robot sensors. Yeah, does it make sense? So all these are basic localization concepts. So I'm going over them fast in any case because that's not the point still of this class. Yeah. So yeah, now if we want to make sure that our localization is working properly, we can move the robot a little bit around using a teleop node, keyboard teleop node. Yeah, you have the command right here. So let's try it. Let's execute the teleop node in another shell. So we can, if you want here, rename the shells. When you start having a lot of shells, it gets quite messy. So it can be helpful to name them so that you know what is running in each one. For instance, in the first shell, I am running the simulation. Yeah. So if you double click here in the tab,
it's going to give you the, not double click, sorry, it's only one click. So if you click here, it's going to give you a possibility to rename each terminal. So this one, I'm going to rename it to localization. Here I have localization running. And in the third one, I have RVs running. So let me rename them. And now I'm going to start a fourth terminal here. And here I'm going to start a keyboard teleop node. Yeah? By using the command, which is provided here in the notebook. So let me paste it here. And now I can move the robot a little bit around here using the teleop program. See, my robot starts moving here in the simulation. So let me move it around a little bit like this. There we go. Rotate a little bit. Yeah, and as I move my robot around, as you can see, the localization particles keep improving and the guess keeps getting better, okay? Right now the localization is not very good because the orientation that I have set is wrong. So actually I have set an orientation in this direction, but the current orientation, as we have seen, is on this direction, right? So we can fix this. So now the robot is in the middle and oriented more or less like that. So I'm going to fix it here, like this. There we go. And let me keep moving the robot. So I know that the localization is not quite good because of the laser data, which here we cannot see it very well, but if I increase here the size of the laser display to, let's say, 0.5, yeah? So for if the localization is perfect, we should see that the laser data is matching the one with the map, okay? So let me go back and move a little bit the robot around and see if this improves my localization, which it should. Let's see. Oops. Okay. All right. See, so now my localization is getting much better. As you can see, it's correcting all the errors, and the localization it's making its work. So it's providing an accurate localization. And the more I move the robot around, the better the localization is going to get, right? All right. Yeah, so far so good. Are you following? Let me know here in the chat. So far we have seen a first method of how to set the initial position of our robot, which is using RVs and using the 2D pose estimate tool. Bibin Thomas says yes. Okay. Perfect. Then, yeah, so we have seen the first method, which is using ROS2 and the 2D pose estimate tool. Yeah, this is one of the most common methods. However, sometimes, maybe, we don't have access to ROS2. So we cannot set the initial pose of our robot using the 2D pose estimate, right? So we are not going to always have access to ROS2. Then how else I can set the initial pose of my robot? Okay, so another method is through the configuration file. Okay, so if we come back here to the code editor, yeah, you are going to see that the localization system, it uses some parameters which are defined here in a configuration file. Yeah, you can double click here in this file to open it. And here you are going to see many parameters which are related to AMCL. Okay? We are not going to go over this. But you can add some parameters here into the configuration file for the AMCL node in order to set the initial pose of the robot from here, from the configuration file. Okay? And how can we do this? Okay, so we are going to do it now all together manually. So for this, the first thing that we are going to do is to generate another configuration file. So we can duplicate this one by right-clicking here on the file in the code editor, right-click, and then select duplicate. This is going to generate a copy of this file. And then I'm going to rename this copy. Yeah, again, right-click in the copy, rename, and I'm going to name it here as, let me check in the notebook. It's AMCL config initialized. So let's give it this name as the name that the notebook suggests, which is AMCL config initialized.yam. Okay? So now I have two files, AMCL config and AMCL config initialized, which are exactly the same. Okay? Then, now to this initialized file that I have just created, I'm going to add the following parameters. Yeah? So you can copy this directly here from the notebook, copy it, and paste it here into the AMCL config initialized YAML file. You can paste it here at the bottom, yeah, here. Make sure to keep the indentation, yeah, like this. And then this is basically adding two parameters. First one is set initial pose, which we are setting to true. Okay, this means that now we are going to set the initial pose from the parameters. Yeah? So set initial pose parameter to true. And then initial pose parameter, here we define the X, Y, and yaw orientation. The yaw is the orientation of the robot. Yeah? So with these three values, we are going to be able to set from here the initial pose and orientation of my robot. Right? Then, what else? Okay, so I have created here my new configuration file with the new parameters. So now I need to update my launch file, right? I'm going to update the launch file in order to load the new configuration file. Instead of, as you can see here, in the current launch file, we're loading the AMCL config YAML. So I'm going to update this here in order to start the AMCL config initialized.yam, which is the new configuration file that I have created with my new parameters, right? So let's update also the localization file. Yeah? Are you following? Am I going too fast? Are you all lost already? Too fast, says Nuria. Okay. Where are you, Nuria? In which step are you? Let's try to slow down a little bit so that everybody can catch up. Okay, so let's recap here. So what have we done? We have created a copy of the AMCL config YAML file, right? We have created a copy which we have named AMCL config initialized. Yes? Then in this new configuration file, we have added some parameters here at the bottom. Yeah, the parameters, you can copy them directly here from the notebook. Okay? You can copy this directly from here. Yeah? And you are going to add them here at the bottom of the configuration file. Yeah? So you are going to have something like this. Then, once we have created our new configuration file, of course, we need to load it. Then, in order to load it, to load this new configuration file, we have to come to the launch file. The launch file that starts the localization system. Then if we open the launch file, which is named localization.launch.py, it's inside the launch folder here, in the localization server package. Yeah. Then here, all we have to do is to look where we are defining the name of the configuration file and change it. Yeah, we need to change the name of the file by the name of the new file that we have just created. Yeah? And then, once we have updated our launch file so that it loads the new configuration file that we have just created, all we have to do is to recompile, right? So now we have to recompile. Step 5. Okay? So let's just stop everything here. Let's just stop the... well, actually, no. Let's not stop this, because you might ask now, okay, Alberto, but why are you using these values and not others? Okay, so you can set the values that you want, okay? So how, I'm going to show you a trick in order to get easily these values. So for instance, let's say that we want to initialize our robot here in the center and with a certain orientation. So we want to initialize our robot. We can use the post estimate tool in order to get these values. Okay? How we can do this? Okay, very easily. So we can click here onto the post estimate and then select a specific orientation. So right now the orientation of the robot seems to be like this. So if I copy this orientation like this, using the 2D post estimate tool, okay? And now, if I go back to the shell, to the terminal, where I am running RVs, you are going to find a message like this one. See? We have this message here from RVs, which says, setting estimate pose, position, and orientation. Okay? So from here, I can get these values. All right? So we can use the values from here in order to use them in our configuration file. So I'm going to do this right now, okay? Let me get the values directly from here. So in the position, we have the X, Y, and Z, right? So let me copy the X value here into the parameter file X field, and the Y value into the Y field. Okay? And finally, for the yaw, we are going to use the value here from angle. Yeah? This angle value is the equivalent to yaw. Okay? So let me copy the value here from angle and use it for the yaw. Okay? So, recap. What have I done? I have used the 2D pose estimate to set an initial pose here in the map, and then I am using the values to set the same pose from the configuration file. Yeah? Do you understand what I have just done here? This trick that I have used? Yes? Yes, says Logan. Okay. Perfect. So let's try it. Then now I'm going to stop everything. Okay, I'm going to stop here the teleop node. I'm going to even stop RVs also. stop localization, of course, right? And now, what I need to do is to compile, first of all. Yeah, I have to recompile. So, in order to compile, we need to come here to the root workspace. Yeah, ROS2 workspace is the workspace where we are working, right? ROS2 workspace is the workspace where I have my packages. Between them, the localization server package. Yes? So I have to come here to this path, home/user/ROS2 workspace, and here I can run the command to compile. Call build packages select localization server. Yeah? I don't have the command here, but I can paste it here if you want it to make things easier. I'm going to paste it here in the chat. Okay? So this command, call build, is the compilation. So you can run call build directly, but that is going to compile all the workspace. And in this case, we only want to compile the localization server package. So we can specify this packages select in order to only compile this localization server package. Yes? And why do I need to recompile? Well, because first of all, I have added a new configuration file, and also I have updated my launch file. So I need to recompile my package so that the new changes are taken into account, right? So let me run this command, and this is going to start compiling the localization server package. There we go. Okay, it has finished compiling. So now let's source our workspace. Yeah, important always before after we compile. And now what we can do is to relaunch the localization system. But before this, we are going to start RVs, okay, so that we can visualize everything properly. So let's start again RVs here from 0. Remember, we are going to have to load the configuration file. Yeah, on File, Open Config, we come here to User, ROS2 Workspace, SRC, Localization Server, and we select localization.rvs. Okay, and for some reason, I am not getting them up now. Oh, sure, because I am not publishing yet. Yeah, okay. Yeah, so at this point, we are not going to see anything, right? We are going to have it like this. Then once we have RVs started with our configuration file, we are going to start a localization again, okay, using the new configuration file. And what is going to happen? So let's start it and let's go to RVs to see what happens. Okay, so what happens is that my localization gets started using on this initial pose. As you can see, the arrow is the same one as we used before. Is this arrow position, yeah, which is the position that the AMCL node is giving. Yeah, this arrow, if you come here to the pose with covariance, we are getting it from the AMCL pose topic. Yeah, so this arrow is the current position that the AMCL node is providing. Yeah, and this position now is being initially set by our configuration file, by these values. You see? Yeah? Does it make sense? As you can see also, we are not getting anymore the messages that we were getting before. Do you remember? The first time that we started our localization system, if you remember, we were getting these messages. Yeah, do you remember? We were getting this, hey, AMCL cannot publish posts or update the transform. Please set the initial post. Do you remember we were getting these messages the first time we... So now we are not getting these messages anymore, obviously, because we are setting our initial post from the configuration file. Yeah? Logan says perfect. What about the rest? Are you following? Yes, no? Yes, says Jingyu. Perfect. Okay, don't worry also if I am going too fast. Maybe I am going over some things fast. Okay, so in case that you have you want to review this later at a slower pace, you are going to be able to do it. Okay, so you are going to have this project, as I said at the beginning, forever, so you can review it whenever you want at your own pace. Okay. Perfect. Then what else? So what other options we have? We can also set the initial pose from the command line. Yeah? So the initial pose can be set using a topic which is named initial pose, right? So if we come here to a shell, another shell, and I run a ROS2 topic list command, you are going to find a topic here, for instance, which is named initial pose. Then we can directly publish into this topic in order to change the initial pose of the robot, right? So how can we do this? We can do this by using a command like this one. Yeah, we can publish directly from the command line tool using the ROS2 topic pub command. Yeah. So let's copy this command here from the notebook. Let's select everything, copy it, and paste it, for instance, here to a blank terminal that you have. And as you can see here, we are using the ROS2 topic pub command. We are publishing into the topic initial pose a message of the type pose with covariance stamped. Okay, this is the message that the initial pose uses. So we need to publish this type of message, yeah? It's a pose with covariance message. Then we specify the frame ID, which is the map. The pose that we are going to set is, of course, with respect to this map. So the frame that we want to set in our message is map, right? And then we define a specific position and a specific orientation. Right? I don't know why the message is getting this strange format. Let me resize this clear and paste it. Yeah, like this. So we have the frame, and then we specify a pose, position in X and Y, and an orientation. Right? So what is going to happen if I publish this message? Right now, what is going to happen here? Can somebody tell me? What are you expecting to get? So what is going to happen is that my broadcast is interrupted, says Dummy. Hello, hello. Are you there? Hello, hello. Can you hear me? Yes, no? Okay. Is it the stream is working okay for you guys? All good. Okay. So maybe it was a small freeze, Dummy. Okay. So yeah, everything is fine. Okay.
Yeah, so Logan said robot to move to x equals 0, 2. Well, more or less, but that's not exactly true. So the robot, our robot, in the simulation is not going to move anywhere, right? The robot is not going to move. What is going to happen is that the initial pose of the localization system is going to be updated to this position, yeah? To this position with x equals 0, 2, and more things. X equals 0, 2, E equals 0, Z equals 0, and orientation equals W1, right? So basically, the pose here, this arrow, which is the pose of the AMCL node, is going to be updated, right? So let me publish the message and see what happens. Let's publish the message and see if our pose, initial pose here, is updated. See? So my pose has changed, and therefore the arrow has changed, right? Yeah, and if I publish again with a different value, for instance, let's put here 0.5, then again, and let's put here 0.5 also, right? In X and Y. So the position is going, the initial pose and the arrow is going to be updated. Let's wait. There we go. See how it changes? Yeah? So we are updating the initial pose. We are setting the initial pose of the robot directly using the command line and publishing into the initial pose topic. Yeah? Does it make sense? Yeah? Hello there, dummy. Hello there. Okay, perfect. So we have seen already 3 different methods of setting the initial pose of the robot in ROS2 Navigation, right? So we have first seen how to do it directly using RVs and the 2D pose estimate tool. We have seen how to do it using the configuration file, yeah, with some extra parameters. And we have seen right now how to do it directly from the command line tool, publishing into the initial pose topic, right? And we are going to see still a 4th method, one last method, which is programmatically, yeah? So we are going to create a very simple and very dummy Python script, Python node, which is going to set the initial pose from a ROS2 node, from a program, okay? So we are going to create a new Python script named like this, initial pose pub.py, into our localization server package. So let's come here to the code editor, and inside this localization server package, this localization server folder, sorry, where you have this init.py function, here you are going to create the new Python script, which we are going to name initial pose pub.py. Yeah? Initial pose pub.py. And now we are going to paste this code here. We are going to paste this code here into our Python script. Yeah? So, in our localization server package, inside the localization server folder, here where you have the init.py, you create a new Python script named initial underscore pose underscore pub.py. And then inside this script, you paste the code that you're going to find here in the notebook, in the Jupyter notebook. Yes? Then this is a very, very simple ROS2 node, which we can have a look very quickly.
So as you can see, we are creating a class here, a Python class, and then we are creating two objects, one publisher object and one subscriber. Yeah. So we are creating a publisher object, which is going to publish into the initial post topic. Yeah. So now instead of publishing directly from the command line, as we were doing here, we are going to publish here from a ROS node. Yeah, but we are going to publish in the same topic, initial post, and we are using the message, which is post with covariance stamped, right? And then we are creating a subscriber element, which is going to subscribe to this clicked point topic. Yeah? What is this topic? Well, this topic is a topic which receives information, receives messages in case that we use the publish point tool here from RVs. Yeah? So we can use this tool, publish point, in order to click somewhere in the map here, as you can see. So whenever you use this publish point to publish a point anywhere here in the map, when you do this, a message is published into this clicked point topic. So we can subscribe here, for instance, directly ROS2 topic echo clicked point. Right? Then now, as soon as I use the publish point tool here and publish a point in the map, there we go. You are going to see here that a message is published here into this topic. Yeah? So what we are doing here from our script is to subscribe to this clicked point topic. Yeah, in order to capture this data. Yes? Then, of course, I have a callback for my subscriber, which basically what I am doing in my callback is to get the X, Y, and Z data. Yeah? I am getting this data, the X, Y, and Z data from the point that I have published. Yeah? I am getting this data in my callback, right? And then I am calling a function which is named publish. And I am passing this data to this function, this publish function, right? And then within this function, what I am doing basically is to create the message. So I define the frame and I establish here an X, Y, and orientation, okay? So the X and Y values are correct. This value is not correct, okay? Actually, because the data from the message, as you can see, the message, the Z coordinate is from the point, right? This point, in this case, is going to be always 0, yeah? So actually, this data is not the zeta. It doesn't reflect the orientation, right? Because whenever you publish a point, you cannot define the orientation, okay? So in this case, here, for this script, we are doing this, which is not accurate, okay? But it's just to demonstrate the concept, okay? But keep in mind this, okay? So this Z point is not equivalent to the Z or the orientation, okay? Here we are just doing it like this it's a kind of hack, okay? But here, if you want to improve this, script, maybe you can set a defined orientation, yeah? So with this method, you are not going to be able to define the orientation from the point, of course. So this is a limitation, right, of this method. Well, in any case, then, you use the data of the point in order to publish a message, right, into the initial post topic, right? Okay, then let's test it. But before testing it, yeah, so before testing it, we need to generate an entry point, right? So you are going to have to create inside the console scripts of the setup.py, yeah? So in the localization server package, you open the setup.py script, and then here you need to add an entry point, yeah? And you can copy this line directly from here, or you can just copy the whole thing, or only this, however you prefer. I'm going to only get this in order to generate here my entry point from my initial post pub script, yeah? So basically what this is going to do is to generate an executable from my Python script that I'm going to be able to run, yeah? Okay. Then, once I have this, I'm going to stop everything one more time. Let me stop everything. Let me stop everything here. And I have to recompile, right? So I need to recompile here. Then let's recompile our localization server package. Let's source one more time. And let's run it. Again, we are going to start also RVs to visualize everything. And remember to load the configuration file. ROS2 workspace, src, localization server, localization.rvs. All right. There we go. So we have our localization system up and running and RVs up and running. So only thing missing is to run our node. So let's source here our ROS2 workspace. And now we can run our node with the following command. Here from the notebook. Yeah, the last one that you have here. ROS2 run localization server initial post pub. Yeah, this is the executable that I have defined in the setup.py file right here. So let's run our node, our ROS node. And then what do I need to do now in order to get the post initialized? Can somebody tell me? What do I need to do? How does my ROS node work? Click on symbol. You mean in the publish point? Exactly. So we need to use the publish point, right? Because our ROS node, as I have just explained it, is listening to this clicked point topic, right? So if we come here and we publish a point anywhere in the map, the robot is going to get initialized there. So for instance, if I click here, see, automatically the initial pose of AMCL comes here. If I publish anywhere else, let's publish a point now here, the initial pose gets updated here. Okay? And yeah, so basically that's it. We have finished it. Okay? So yeah, I know that I have gone over some parts quick, okay? But I wanted to focus on explaining these different methods. There are even more methods, okay? So there are more methods that you can use. For instance, you can use the Robot Commander API, which is another very cool method that I have not explained. But yeah, so in case that you want to get a deeper knowledge of localization or any other concept related to ROS2 navigation, like mapping, obstacle avoidance, path planning, etc., you have the complete ROS2 navigation course. Yeah. So we have just published this course, this new ROS2 navigation course based on Galactic, where you are going to to find detailed information about everything related to ROS2 navigation. Yeah? So this class, it was just to show some quick concepts, some ideas. But if you really want to learn how everything works and all the things that are behind the scene, how to configure ROS2 navigation for any robot, etc., you have everything explained here in the complete ROS2 Navigation Galactic course. Okay? So yeah, very quickly now, right before closing the class, I want to know your opinion, if you like this class, if not. So I'm going to activate here a form that you can so that you can rate from 1 to 5 stars today's class, if you liked it, if not, etc. So let me activate it right now. There you go. So you should see appearing here a form like this one so that you can rate the class, okay? So please do it, and this way we can get some feedback from your side, if you liked the class, if not, so that we can keep improving every time and increasing the quality of the classes. Okay? So yeah, that's all from my part. Thanks a lot for being here with me. I hope that you enjoyed this class. I hope that you learned something, at least. And yeah, as always, remember that I'm going to come back next Tuesday with another open class. Next open class is going to be related to gazebo simulations, okay? So stay tuned for the next open class, and until then, as always, take care and keep pushing your ROS learning. Bye-bye.